Hello everyone, I am Satyam Rathore, Scientist B at Bureau of Indian Standards. Welcome to the another training module. Today I will discuss the topic safety requirements for medical equipment. We will go step by step to understand why safety testing is important, what risks are involved, and what standards we must follow. This presentation will give you an overview of basic safety in medical equipment. We will focus especially on electrical safety since most medical devices run on electricity. By the end, you will understand the main risks and how to prevent them. So why safety testing is required? We test medical equipment to make sure it's safe to use in hospitals. Unlike homes, hospitals involve open wounds, tubes and invasive procedures. That means even a small fault in equipment could be very dangerous. So what are the hazards in medical environments? In a hospital, the body's natural protection like skin may be broken. Also patients are often weak or unconscious, so they can't protect themselves. At the same time, machines use electricity, radiation or chemicals, all of which are potential hazards. So different types of injuries in India. Every year, device-related patients' injuries are reported in India. The sad part is many are preventable. Most happen because staff lack proper training or only open the manual when something goes wrong. So what is electrical safety? Electrical safety means preventing harmful shocks, fires or equipment damage. It is a shared responsibility, not just doctors, but also nurses, engineers, manufacturers and the hospital administration all play a role. So what is the main purpose of safety testing? The main purpose of safety testing is to confirm that devices are safe for patients, staffs and even maintenance workers. Remember, a safe device today may become unsafe tomorrow if not checked regularly. Then what is electric shock? An electric shock is the body's unwanted reaction to current. Depending on the strength, it can cause muscle spasm, burns, breathing failure or even stop the heart. Three phenomena of shock. The shock can harm the body in the three main ways: by stimulating nerves and muscles uncontrollably, by producing heat in tissues causing burns, by chemical effects that damage cells. All three can be dangerous. So there are two types of shocks. First one is macro shock. Macro shock is the type of shock most people know. It happens when current flows through the body but not directly the heart. It can be painful and harmful, but usually needs higher current. Then microshock. Microshock is more dangerous in medical settings. Even a tiny current, too small to be felt, can cause ventricular fibrillation if it reaches the heart through catheter or wires. So what are the physiological effects of electricity? For electricity to affect us, the body must be part of the circuit. Current enters at one point and leaves at another. The higher the current, the stronger the effect, regardless of voltage. Then burns. So when current passes through the tissues, it generates heat. If concentrated in a small area, this heat causes burns, sometimes deep inside the body, not just on the skin. Then muscle cramps. When current stimulates muscles, they contract. If it is continuous, the contraction becomes tetanus, meaning the person can't release the live object. That's why some victims remain stuck to a wire. Then respiratory arrest. If electricity affects the chest muscle, they freeze. Without movement, the person can't breathe. This is respiratory arrest and it can quickly become fatal. Then cardiac arrest. The heart is a muscle that pumps blood by contracting and relaxing. If it goes into tetanus due to electricity, it stops pumping altogether. This is cardiac arrest. Then ventricular fibrillation. So in fibrillation, the heart beats irregularly. Instead of pumping, blood flow stops and without immediate correction like defibrillation, the patient may not survive. So what is the leakage current? Leakage current is small flow of current that escapes from equipment to ground or to the body. Some leakage is unavoidable, but too much is unsafe. So leakage current testing. So to control leakage, we test with the safety analyzer. If the current is within standard limits, it's safe. If not, the equipment must be repaired or rejected. So what are the critical points of electrical safety? So some critical safety points are: check electrical installation often, reject damaged plugs and cords, only use devices that are tested and approved, avoid radio frequency interference from mobile phones. These simple steps prevent many accidents. Then equipment classes. So medical devices are grouped into classes based on protection against electric shock. So now we will learn about IS 13450 Part 1 standard, which applies to the basic safety and essential performance of medical electrical equipment and medical electrical systems. This standard covers medical electrical equipment and medical electrical systems assembled by several medical electrical equipment component that is used in above equipment. Aspects covered by IS 13450 Part 1. IS 13450 standards ensure safety covering general design, protection from hazard and electromagnetic compatibility. Then we will learn about IS 13450 Part 1 Section 2. This applies to the basic safety and essential performance of medical electrical equipment and medical electrical systems. It also applies to the basic safety and essential performance of medical electrical equipment and medical electrical systems. In the presence of electromagnetic disturbances and to electromagnetic disturbances emitted by medical electrical equipment and medical electrical systems. Then basic safety about electromagnetic disturbances is applicable to all medical electrical equipment and medical electrical systems. Then aspects covered by IS 13450 Part 1 Section 2. First one is risk management process for medical electrical equipment and medical electrical systems, general test conditions, list of tests, document of the test, electromagnetic emission requirement, protection of radio services and other equipment, electromagnetic immunity requirements. To conclude, safety testing is not just a formality, it saves lives. Everyone from doctors to engineers must take responsibility. By following standards and doing regular checks, we protect both patient and ourselves. Thank you.